Okay, let's go ahead and get started. And we finished 14 Monday, and then we got 15 to go over. Sure, my phone's on vibrate, which is not a lot of stuff in 15. 14 had a whole lot more stuff. Have y'all got any questions on 14? Particularly TCP and the three-way handshake and windowing. So that's really three big things. That and ports were the big things out of chapter. UDP was obviously in there too, but there's not much on UDP other than know it's connectionless and not reliable. Okay. But TCP, you need to know the three-way handshake. Make sure you've got that term down with TCP. And be aware of what's involved in the handshake, of how it starts. And then know what windowing is and how windowing works. We're sending a set of data at a time. Now, one thing I did not mention on the windowing, I briefly went to mention it, and then I didn't mention much, but it is in your book actually, or your materials. There at the end, near the end. Somewhere in there at the end of the windowing, they do mention also the selective windowing. I'm trying to find where that spot is now. But they do mention in this book selective windowing somewhere. And I do not see it today, but yesterday when I was talking to the group online, I saw it. Now I don't see it for some reason. Oh, there it is. Okay. Because in section 14.6.3, they do mention about that there is selective acknowledgments. And with that, instead of where I told you if you sent one, if you had a windowing size of 3 and you sent 1, 2, and 3, and 1 and 3 got there. With regular windowing, your acknowledgement you would send back would be 2. Okay, because you want to start with 2 and send 2, 3, and 4. With selective acknowledgements, and this is new, so it's not available everywhere, but where it is available, actually just in this book and I haven't looked in the online materials for sure on it, but it's got to be there. So either from last January a year ago or from when this came out, so obviously from last January because I want to print book. That, and then in my 2601 class, my security class for operating systems I'm teaching, that it mentions selective acknowledgements also. What it would send back is, instead of sending just 2 on a selective acknowledgement, which is an SACK, as opposed to an ACK, it would put 2 and 4. And then that would tell the sending machine, send 2 again, but really start from 4. Okay, so we send 2, 4, and 5. So everybody follow on that? Is what the request is to send, because it's got 3 and it'll be able to use it with selective acknowledgement. Now with normal windowing, it sends 2 and starts from 2. Okay, which more than likely, if you get questions on any exams at this point, it could be different in the test in here, but I doubt it very seriously. Because first off, you've got a test that covers 3 modules, I think. There's not much out of there, but odds are getting specifically on that, it's not very big. But if you were taking a certification test on networking or whatever, at this point, everything I have seen, and I actually took networking plus last year, nothing's been mentioned about selective acknowledgements. I really wasn't even testing. I had missed it. Well, I didn't have the print textbook first off. And I have to look at the online materials to make sure it really is there. It should be. But I didn't catch that in there until when I was going through in 2601. And they actually have a separate slide for it in their PowerPoint. I'm like, whoa, I've heard this one before, and sat there and read it for a little bit. So be aware of that part too, and that it is mentioned to you. But the other part will be a lot of machines aren't going to do selective acknowledgements at this point. So you're going to have two machines that you're talking that both use selective acknowledgements, which is a new concept. It would speed things up, obviously, because when we're talking about a window of the size of 3, it's not that big significance, okay? If you had a window of size of 20, if you lost the second segment going across, then that means there is a large amount of resend on it, okay? Where with selective acknowledgement, if that's all you lost, you'd be able to use those other 17 that we would have lost before for 18 segments that we would have had to resend under the old one. So we follow on that? So picture it in the big picture in terms of the need for SACK. All right, chapter 15 is the application layer. So we have made it to the top of the whole of the two models. We're looking at the application layer really in terms of application on both of them. Although when you're looking at it from OSI, we're going to briefly mention presentation and session layer also. Although that's very brief, that most of what this chapter is, because it's like 2 paragraphs or something. Most of what this chapter is about the application layer in OSI, which is just part of the application layer and TCP/IP. Everybody follow that? But remember, the TCP/IP one includes application, presentation, and session in OSI. Y'all got that part? So between these two chapters this week, we're actually covering 4 layers of your 7-layer model, okay? But that's the way those work, and that your heaviest stuff in them really is those bottom 3 to 4 layers, okay? The transport layer's got a decent amount of stuff, but it's not as heavy of stuff as you had in layers 2 and 3, and even back there in layer 1, okay? Layers 2 and 3 were the heaviest layers. So here we're looking at the application layer, but let's first mention about the presentation and session layer. Presentation layer, which is layer 2, not layer 2, layer 6 on the OSI model. What it's going to do is it's taking the data, if you're going down in the model, so you've had some application has passed off stuff to the network model. So at the presentation layer, what it does is it takes that data that was in the applications format and changes it into a format for the network. So it changes the data around a little to get it formatted correctly to handle on the network. Y'all follow that part? So we're taking a PowerPoint presentation and switching it into a network format. So we're doing a little bit of play with it to get it where it's going to work better to go across the network. Okay? That's what the presentation layer is doing, going down, coming back up. Presentation layer is taking that file, because remember, on layer down there on the transport layer, remember that it had split the data up going down into segments and it put it back together into a file going back up. On the presentation layer, what it's doing, coming back up, then it takes that set of data, it's all big one chunk again, because transport took care of that, and then it's converting it into the format that the application will work with, that it's going to hand it off to. So everybody follow on that, what presentation does? So presentation is just putting it in a presentation format for either the application or for the network, depending on which direction we're going. So it's just, how's it look? And that's what a presentation is. It's something that you look at, okay? So the name of it makes some sense there for you. That's what's involved there. One of the things that's involved in there on the presentation layer also is if there is compression of the data going to be used to go across the network, it compresses it on that layer. And if it's going to be encrypted, it will also work with that on that layer too. So that's the other piece of it, because if we're going to encrypt it going across the network, it's at the presentation layer when we encrypt it. And when it gets back to the presentation layer is when we decrypt it. Likewise, if you're going to compress it, there's where you're going to compress it and decompress it. And that's going to be the biggest part of what you're really doing there in terms of presentation, okay? Is encryption and compression. Now, as far as the session layer, what the session layer does, it establishes the conversation, the connection between the two devices, and maintains that connection. When I took this class, that was in 2001, so 20 years ago, but it's still the same. There's different things in here, obviously different, obviously like the selective acknowledgement, that is totally new. But this would be exactly the same about the session layer. Is the session layer maintaining that, and my instructor's comment to us was to think about the session layer like a secretary. And session and secretary both start with the letter S, which works even better, because now you've got something common between the two of them. If you've got two executives of big companies, these big CEOs that make millions of dollars, okay? If they want to call another CEO or call somebody else high up, or you get to the big politicians, you get the same thing on it, okay? That, because you wouldn't find Joe Biden picking up the phone and making a phone call. Very likely, although it's possible. I do remember on Obama that he was a particular stickler on wanting to call. When he got elected, there was a big controversy with the Secret Service going, he couldn't use a cell phone, and that if he was going to use a cell phone, they had to get a special one made for him. For the simple reason, your cell phone tracks you. And if he had a regular cell phone, which is what he had, and actually if I remember right back then it was BlackBerry, which I know is historical for y'all now, but was the big one at that point, okay, was that it's got tracking information on it, and guess what? If he was carrying that phone, a regular BlackBerry around on him, or today if he was carrying a regular iPhone or Android on him, that we're locatable, that if somebody wants to determine exactly where we're at, that they're, one of y'all decides that y'all just totally dislike me and that you want to take me out on it, you can track me off my telephone. Okay, even if I turn off tracking on it, there's still some tracking that can be done. If you're not sure on that, read the police reports on different things that happen and where they determine what really happened because they were able to trace somebody's cell phone or they catch somebody on it. Okay, so I know a lady that went through a whole complicated suicide procedure a year ago, and that nobody was sure what had happened, that other than she was dead, but there was no weapon there or anything, but they were pretty sure it was suicide and that she was dead laying there in the cemetery. And how she get there, because her car wasn't there and anything. And it wasn't a case of she would have walked to where she was. And that where the GBI finally solved the whole thing and presented on it was that they traced her cell phone records on it. Figured out, and they haven't yet ever said or figured out, one of the two, I suspect it's the second, who it was took her there, but they said somebody took her there and took the gun back with them. But they were quite confident on it that it was a suicide on it, that it wasn't a murder. But she was also up on a charge that she was facing in court for killing somebody, which was a question of was self-defense or whatever. So it was one of those that was going to be big stories. And so they had determined all of that off of it just by following her cell phone number and about how she got there. But they were still trying to figure out who took her there. And I don't know if y'all are aware of this, but suicide is actually illegal in the state of Georgia and in most states. Okay? So that means whoever drove her out there, if they knew that's what she was doing when they left her out there, although where she died at was at her daughter's grave. So the person that took her out there may not have known, but somebody took that gun away, so somebody knew something. Well, probably if they figure out who it was, we'll probably end up with a charge of at least assistance in a murder. Okay? So we can follow things on that today, okay? So in any event, with the session layer, normally you get high up people, and you get like the President of the United States, and normally they don't just make a phone call, although we're quite confident that they do know how to make phone calls, and that some things that we get reports of, we're quite confident that they made the phone call and that they weren't having their secretary call that person. It's very doubtful that Bill Clinton was having his secretary call, what's her name? Monica, okay, to arrange their meetings. We highly suspect that Clinton called her himself, okay, but normally that's possible, though, that he did have the secretary call her every time. I'm not saying not, okay, but you'd think probably not, okay? But normally, if one CEO wants to call another one, you're president, CEO of Nabisco Foods, and I'm president, CEO of XYZ banana company that you deal with. If you want to talk to me about something one day, what are you going to do? You're going to tell your secretary to call Dr. Watt. And what's going to happen on my end? Is the secretary going to get a hold of me? No. My secretary will answer the phone. The two secretaries will establish that he's there, I'm there, and then pass the call off to us. Does that make sense? Then, at the end of the conversation, he and I will pass it back to our secretaries, because maybe he called me about seeing about if I want to go bicycle riding in the park tonight, or that do I want to go play golf with them tomorrow morning. Okay, or maybe it was because he wants to buy a vegan bananas from me or making whatever. Okay, we're going to pass it back off to our secretaries and tell them what it is we had discussed about or wanting to do. They will make sure our calendar's clear if it was to go bicycle riding or golfing. And then they will hang up the phone. I'll follow on that. So the secretary did all of that. The session layer is doing the same thing. it actually makes the connection to the other device your device is trying to talk to. It also makes sure that the connection stays there. And if something happens, it's the session layer reestablishes the connection. And it's the session layer that actually does the actual disconnection. Although we saw in TCP, we saw the disconnect on TCP, but that really doesn't disconnect the connection. Y'all follow on that? So that's what the session layer is doing. Is it's establishing, maintaining, and disconnecting the connection. And that's all it does. Now, the application layer is what the chapter is really about. And they do mention, I think it's into the application layer. So with the application layer, this is the one thing that confuses some people. Make sure you've got straight in your mind that the application layer is not where the application is actually at. So if you're using Chrome as your browser, Chrome is not on the application layer. Chrome talks to the application layer. Y'all follow on that? So the application layer is the part of the networking whole thing that does the connection actually with the application. But it's not the application. Does everybody follow that part? Is that the application is separate. It does all of its stuff, and then when it needs to do something across the network, it sends the information over to the application layer. Everybody follow on that part about the application? That was one thing confused me for a little bit about application layer. I wanted to put the application on there, but it's not there. So we're going to talk about protocols on there, but we're not talking about specific applications there, although that is the protocol that's used by that application. Okay? They do mention to you again about your two models of networking, not the where models, but as far as how networking works out there, that you had peer-to-peer and client-server, which I think we went over back in chapter 1 or chapter 2, way back there at the beginning, back there in the beginning of January. We talked about peer-to-peer and client-server. Maybe you already believe that the class has been going since January, since it's nice temperature out there now, although a little bit cooler this morning. Although it was really pretty last night when I did go bicycle riding in the park. Although Nathaniel didn't need me there to go bicycle riding. Although we're from Battlefield Outdoors, I went riding with them through the park. So you've got peer-to-peer networking and you've got client-server. And that's the two setups you've got out there. Peer-to-peer, remember, says that all of the machines are equals and they're responsible for their own stuff. The security on each machine is the responsibility of that machine. Okay? Peer-to-peer can be done in a little small network, and actually that's how people normally work with networking at home in a real small office type thing where you just got a few machines. We can do peer-to-peer here in the classroom, although our machines in here are actually set up client-server, but we can also do peer-to-peer networking. So he can choose to share a file with everybody else in the classroom. He can go in there and you go in the properties of the file in Windows and you can choose share, and at that point you're doing a peer-to-peer networking. And it's his responsibility to watch and make sure of who it is gets to that file. It's not the server's responsibility at all. He sets up the rules on it right there of who he allows to share that file. Peer-to-peer, so that's local. Peer-to-peer can be done across the internet also. And y'all may have all done some peer-to-peer networking on the internet. If you've ever gone out there sharing songs or videos, or games for that matter, because those are all three done on a peer-to-peer out there sometimes. And actually, when you play some games, that you do it on a peer-to-peer approach where you're playing a multi-person game, but you're doing it across the internet, and you may well be doing it peer-to-peer, where it's not a central controller on it. In some games, yeah, it is. But in other games, you can set up and you can choose to connect with a person, and there's no central watching of it or anything else. It's just between you and them. I'll follow that. Or you can go out to certain sites, although these have reduced tremendously because there's been all kinds of court fights on them. They were really popular in the past. And get different things to share. Music being and videos being really big ones in the past, but there was all big copyright issues and everything else on that. And they do it peer-to-peer on purpose. Because if you did peer-to-peer, there was no central computer that kept all of that information. And so that if she wanted to get a file that I had, that I was willing to share, she would be logged across to my computer and get it. Y'all follow on that? Not going to a central server, and it's not traceable on it really. It is traceable to a degree, but not really, because it's not being a central spot kept on it. Hopefully I'm keeping track of who I share the file with, and she could get the file from me and have it. May have been a video, may have been a music file, may have been something else, okay? Could even be where you're taking a class from me, and that where I needed to let you get a copy of Windows, but the copy's not available through Microsoft's Azure site. And so I've actually put them out there on OneDrive before and share with a student. And at that point, I'm doing peer-to-peer with that student. I follow on it. Doing it completely legal on it because they got to have a license key that I supply to them to use it and everything. Where in the other case of her and me, it may not have been legal. She may have been getting a song or video that wasn't a public domain one that you're supposed to have a license for, that you're supposed to buy your own copy of. Now, I'm not saying she would do that, okay? Just using that as an example on it, okay? And that's where there was big problems in the past. So you had Napster and Nutella and some others all had big issues on that where they went to actually doing that approach and were massive on it. And there was all kinds of court fights and trying to block that all out. Now, they're still limited out there on it, but they're real limited on what they can do and how they do. And there's others that have popped up now too. So there's different ones, but that doesn't seem to be as big of a thing as it used to be. And then YouTube's obviously continuously doing all kinds of weird things on that too, because every Sunday they catch me on complaining that some copyright-owned group somewhere in the world claims that they own the copyright to a melody of some song that's in the hymn book that the church sang. And they're going, that's a copyright violation. And I'm going, no, it's not. You don't own the copyright on a song that was written in the 1400s. Because copyrights don't last that long. 75 years, I believe, is what the amount of time is now, okay? Or 75 years beyond the life of the person that wrote it. Well, if it was written in the 1600s, there's obviously no copyright on that melody anymore. Now, somebody goes and does a specialized adaptation to it. Yeah, there's a copyright on that, but what they've been claiming is just copyright on just plain melody, which is not correct. So I have to file an appeal every week. And we're actually licensed at my church anyway to sing songs and for it to be done across the internet. And I have to file an appeal and tell them, here's my license numbers. And then after a month, they just, the one that filed the complaint, which they're doing all automatically, doesn't respond to it, and so it dies. Although I had one last month for Jesus Loves Me, I think it was, that they declined my appeal on it. And so now I have appealed their decision on it. But I'm going, you don't have copyright to that melody. And I cited to them when it was written in that you do not own that copyright. Even if you think you do. Now I know what they're doing is they've got YouTube going along with them on it. And they're collecting, and while it's that they make that complaint, if it was a site that actually is monetarized, they collect the money from it for that time period, for that month. And they don't have to return it. So they're making money off of it. And in my case, we're not even monetizing it because there's no monetizing of putting the church services on the YouTube. So they're not getting any money from us, and that's why they're just completely ignoring it, but probably completely ignoring appeals from anybody because all they're wanting is to get that free money for a month that they get for that on it. And they're not having to do anything for it. And there's something wrong with that setup. So client server as opposed to peer-to-peer says we've got a centralized computer that may well take care of our security needs. That's what it does here in school. So that when you sign on to each machine, you use the same sign-on to get onto the machines. As long as you're trying to get on the student domain one. Now, when I go to get on that student domain machine, I have to use a different sign-on than my faculty one, because my regular log-on only gets me onto the faculty domain. It does not let me on student machines, which is why he sits there and watches me have to look down a piece of paper and figure out what my password is every day. Because it's different on there, and that's the only place I use that password. And they gave me one that's this long. And it wasn't one I made up, so I can't remember what in the world, how they did it. I know what they did basically, but how it all plays, I don't know. I can't remember that. And after 2 weeks from now, I won't have to remember anyway on it. So it's not something I try to memorize. I just put a piece of paper every day. But with client server, you've also got a central place where you're keeping files and sharing out. Instead of him sharing the file on his machine, if it's a file that's going to be used by a number of us, he puts it on the server, and then all of us can access it from there. I'll follow on the difference on those. So they come back and mention those to you real quickly. And they mention that there's applications out there, like I just told you, that exist peer-to-peer versus client-server ones. Most things are client-server, but there's things you use all the time that are peer-to-peer. Their example there is Instant Messenger. I can't figure out why you did that one on it. Because it's not used that much anymore, that we're texting and email, that we're not doing instant messaging much anymore, but apparently Cisco hasn't quite caught the fact that instant messaging is dropped off the wayside. Okay? Although you're still doing it some, so we're using Messenger in some, because we are using Messenger like in Facebook or something else some, but there's not that much of that anymore. It's not the big way of communications now. And they throw you a list of some peer-to-peer applications, and P2P is the abbreviation for peer-to-peer. And so they mentioned BitTorrent and Direct Contact, eDonkey, and Freenet. BitTorrent is the only one that I'm aware of on that list on it. But the other thing is on using peer-to-peer applications, be careful on them. A lot of them, that's where you can pick up a lot of infected stuff. Because a lot of things on peer-to-peer do end up infected because there's no central control on it, so there's no overall management of it. Back to Nathaniel sharing a file out to us. We're trusting fully that Nathaniel has kept the file clean and everything, and that he's got his machine protected. So on a server, we got a higher thought on who's managing it, etc. Y'all follow on that? So do be careful if you do use peer-to-peer. Now, the other part of that is there's a lot of stuff you can do peer-to-peer that you can't do. And the other one is if you decide to do some stuff with the dark web, you are doing peer-to-peer there, okay? You're not doing client-server when you get over on the dark web. Simple reason, they don't want a central place that all of that information is being kept. And they don't trust each other either, okay? So then they talk about some basic protocols that are used on through the chapter. They talk a little bit about HTTP, which is the Hypertext Transfer Protocol, and it's using pages that are developed in Hypertext Markup Language, or HTML. And they mentioned that, and that's what you use for your web pages. And that's the base on most of your web pages. Now, they may use other languages mixed into the page, because like I got pages out there that use JavaScript and PHP into them, but they still come back to they're really an HTML behind it, okay? So they mention on that about HTTP. Keep in mind what we mentioned in the previous chapter about HTTP versus HTTPS, but there is the secure one which says everything's encrypted going across it, versus HTTP is unencrypted. If you are going to send information that is PII, personal identifiable information, or anything that's got credit card numbers, checking account numbers, any things like that, you want to make sure it's using HTTPS, which is secure hypertext transfer protocol. I'm trying to be a tongue twister right there on it. Okay, so everybody follow on that? But it is secure in front of the words versus the acronym's got the S on the back. Okay, which can be a little confusing at times too. So be aware of those, know on that, and realize in your browser, you can either look at the full URL up there if it's showing it to you, and if it has HTTPS, you know you're in secure. If it's just HTTP, it's unsecure. Or the little lock that's up there on most browsers, if it's locked, you're using HTTPS. Okay? Then they talk about email protocols. I talked about them a little bit Monday, but I'll mention them again to you on this, because email is a major communications method out there. You'll read stories that says it's dying or whatever, but you know that's not really true. We use other stuff. That you'll read some stories that say people do all their communicating by texting now. Yeah, you do a certain amount of communicating by texting, but you also do certain communication by email. If you want to send a longer message, you're not going to send it on text usually. And that actually you got some people that can't get longer messages. Some people that can't get attachments in texting. So email is still going to be big out there. 3 protocols to be aware of on email: SMTP, POP, and IMAP. SMTP is the protocol used to send any email. So anytime you send a message in email, it is using SMTP. Everybody follow on that? And that gets it to the email server. So, and if you set up an email account, one of the things you may have to fill in there, not very often nowadays, but you may still, particularly if you're using Outlook or whatever, it may ask you what's the SMTP server or the protocol number. And what's the protocol number for SMTP? went over it Monday. What's the port number for SMTP? Hmm?
587.
I
87.
Hmm?
587.
It's 2 digits. I'll give you that. Because actually, of all the ones we went over Monday, there was only one that was 3 digits and one that was 4 digits that I mentioned to you. Everything else was 2 digits. 25. Okay. POP, you're really not going to use it now, but it's still out there. In most cases, it's the way email initially worked up till about the time y'all were born. Okay. Up to the early 2000s. What POP is post office protocol, and version 3 is what we actually use. So you'll see it as POP v3 a lot of times. Is it brings the email down onto your machine. And with POP, you downloaded all of your emails and then read them on that machine. Problem is, if I pulled them down on this machine here, they were on this machine now, but they were no longer on the server. I could tell them to stay on the server, but then when I got home and I connected them, I couldn't tell what I had looked at or anything else about them, or what I'd responded to, because the messages I sent, it's all sitting here, not on the home machine. I'll follow on that. So POP put it onto your local machine. Now, POP is still available on most of your email programs. I don't think Gmail actually has POP, if I remember right. There's one of them that I use occasionally, some that does not have POP available anymore, okay? But you can still use POP if it's there, if you want to pull all your emails actually down onto your machine to have a copy stored on your machine. So some people will do that occasionally as a storage means, okay? Y'all follow on that? And probably still leave them. And that there's usually a checkbox there nowadays, wasn't originally, but you can tell it to leave them on the server, okay? But as a way to pull things down and have them there. So POP, that's what it did. Instead now, what we're using as far as managing them and pulling them down of where we're working with them, we're going to use IMAP, which is the Internet Mail Let me go ahead and show you what it is in here. But IMAP allows us to work with them off of the server, and that means then I can look at my email on here. I can go to an office over in Walker, look at my email there, and it's still exactly the same. I can go home, look at it, it's still exactly the same. I'm looking everywhere. And so you're working with it from the server instead of pulling it down local. So really, to a degree, POP is more really a peer-to-peer type approach to it, where IMAP's more a client-server approach, okay? Y'all follow on that? So you're going to use IMAP normally today. And that's what y'all are completely used to, and what probably is the only thing you've ever done, is use IMAP and not use POP, okay? But be aware of POP, even though it's not hardly used anymore, is still heavily asked on questions. Then they talk about DNS a little bit, and remember, DNS is just our way of changing a domain name and getting the IP address for it. And we talked about that several chapters ago in detail. And remember, it first looks on the machine to see, do we know the IP address for this domain name in our host file? If it doesn't, it then requests it from the server, says the DNS server, and says, do you know? If it doesn't, it then sends it up to the next level. and does that for about 3 or 4 levels, and then there's about 7 root DNS servers in the world that maintain everything it's on about, okay? Normally, it's very seldom you ever access a DNS root server. It's normally somewhere between your machine and higher up that's going to know about any web page you're going to go to, unless you're going to something brand new at that point. And that's why they tell you when you register a domain name that it may take 24 to 48 hours before it takes effect. This is how quick does it get propagated down, and does somebody actually then get the request all the way up and everything set correctly on the machine to ask all the way up, okay? But once somebody does make the connection on several layers up, it's then known further on down. So that's what DNS is there for. They throw you that again on it. They mention about the top level domains, which they mention about being the .org, .com, etc. That used to be a limited number of extensions on that. Now it's unlimited. There's still a list of about 20 that are normally used, but there's been a whole bunch more that different organizations have gone out and gotten, because you can go get an extension by paying a $10,000 fee or something and own some special extension. That if I wanted the extension of WATT to be able to put on all my web pages, I could go pay $10,000, I think it is, to Diana, and I then own the WATT extension. Y'all follow that? And then I could save y'all all different domain names within there. And so there's a bunch of others out there that also got added along the way. Some of them I really don't ever see get used. .museum, I've never seen that one used. Any museum's website that I've gone to has either been .org or .com. So that's the way those work. Some of those are tightly controlled. Some of them are, anybody can go by names under them. .com, .org, .net. And those were supposed to have certain meaning originally, but nobody managed it. So .net was supposed to be sites that dealt with network. So your ISP site and so on was supposed to have a .net. .org was supposed to be nonprofit organizations. Nobody managed it, so Exxon can have a .org if they want. Okay? Just as an example. And it is highly possible Exxon owns Exxon.org. I suspect they do. They spend the $20 a year on Exxon.org. Whether they got it operational or not, I don't know. But I suspect they've got it. Okay? So that nobody else can put up something crazy about Exxon on there. If they don't, I would suggest they buy it, okay? If it's available. And then .gov is controlled. That one actually, you have to get through an approval to prove that you are a government agency to get it. .edu is the same way. It has to be now, it wasn't originally, it's gotta be, for you to get a .edu, it's gotta be an educational organization that is accredited. Now, told you that that wasn't the way it was originally. So there are some, and then exactly how they define accredited is the second question on it, okay? But there are some unaccredited colleges that back there at the beginning, back there in the 90s, got a .edu because they are college, but they're not accredited. And as long as they keep paying their fee every year, they get to keep it. But they could not get it now. Does that make sense to everybody? So they tightened down on that. They went, wait a minute, we need to really make that one on that. .mil, the military controls that one completely. Okay, and I'm not sure if other militaries throughout the world even get to use it, or if it's just U.S. military. But I know the U.S. military gets it, and I'm not sure if anybody else does or not. So there's a whole bunch of those countries have got certain codes also. Because the internet was developed by the United States, we don't have to put .us on the end of all our names like every other country in the world has to. Okay, so the internet is actually American concentric. Then they mentioned the NS lookup, which is just a command that you can do NS lookup and give it an IP address and it'll tell you what the domain name is or vice versa. So it's just a convenient command you can use on it. They throw into you right here. And then they mentioned DHCP, which finishes, well, almost finishes. And they talk about that one. I've mentioned that one briefly before, but I'll mention it to you again. DHCP is where we don't have to put IP addresses on every single machine. Instead, we have them managed by a server. So when you turn on one of these machines in here, it's using DHCP. Odds are your computer at home is also, your phone is probably also. Okay, y'all follow on that? But there's not an assigned DHCP address to it, particularly your phone, because you keep connecting to different networks. So you sure don't want to have an assigned address because that might be already used or not work on the network you're trying to connect to. What it does is when you turn the device on, it sends a request out, broadcast it, and they show you that in a 4-layer approach here in section 15.4.7. That machine, the client, sends out a DHCP discover message. It's a broadcast message. It knows nothing at that point, so it can't be a unicast message. It has to send it to everybody. You could have more than one DHCP server on your network. Most of the time, not, but it could happen. Okay? At home, your router modem is also a DHCP server. Everybody follow on that? That's built in there. So you send out this discover. The DHCP server will send back via broadcast a DHCP offer and tell you, here's an address you can use. But remember, it's got to be a broadcast because at that point, the machine has no address yet. So it can't be a unicast because there's no way to send it just to that machine. So it sends it to everybody. But that plays into one other piece right there. Every machine on the network sees the offer. If by chance some other machine has gotten that address, didn't get it from the DHCP server, or the DHCP server goofed up and has given out that address before, or somebody went in and typed in manually an address into the machine, that machine's going to object and say, whoa, you can't offer that address, it's already in use. So it does play a double usage there on the broadcast, but gets it to the individual machine. The individual machine takes that offer, and normally it only gets one offer. But it's possible it got more than one offer if you had more than one DHCP server. Okay? It will choose one of the offers in that case and sends back a request to the machine that offered it. So this is a unicast message. And says, I'll take it. It's a request to use that number that was offered to it. Everybody follow on that? And then the server will reply back with just an acknowledgement back. And at that point, the server has put it in its table that this number is used by this MAC address. And that machine has put it into its table in its machine, set up its settings. And DHCP does more than just addresses, although that's what you usually see about, and that's the biggest thing it does. it can send out all kinds of information to assign to that machine. Even the name of the machine can be done through it. You can actually set up on the DHCP server that certain address and certain information belongs to a particular machine. So it doesn't have to be that it's just pulling from this big pool. Certain things can be designated for certain machines and used through DHCP, but always the same. Now, what it did is it leased that information. Does it by default on there of 8 days. I don't know where they came up with 8 from, but they did. That they leased it for 8 days. If I'd been the one setting it up, I would have set it up for 7 days. Okay? Because that's a week. But where'd you get 8 from? I don't know. But it is 8 days. After half the time has occurred, the machine will make a request to renew the information. And the server will, if the server's willing to let you keep using it, I'll reply back and acknowledge again and let you have it continually. If it doesn't get the reply back on it, it then checks again at 50% of the remaining time. But it works just like a real lease does in the real world. So if you went and leased a building, you do the same basic thing. Except you wouldn't be trying to renew it at half the time of the lease, probably. Probably more like 3/4 time or whatever. If you leased a building for a year, if you wanted to keep it, or the company that's leasing it to you wants you to keep it, there'd be an offer probably in about 10 months or so of that you want to keep it, or that they want you to see if you want to stay in it for another year. Y'all follow on that? So it's exactly the same approach on it. So that's what DHCP does for you, and that's out there. And remember, that was one that they told you really didn't need to remember on the port numbers, although it did use 2 port numbers, one for the client, one for the server. Which, if I remember right, 67 and 68, I believe is what it was. Okay. And then the last thing to talk about is transferring files, or sharing your files from one place to another. So the first thing to talk about is FTP. We've already talked a good bit about FTP in the previous chapter, so I don't think there's much to tell you on that one. Just remember, it does use ports 20 and 21. So that was the case of where I told you do need to remember 2 ports on that. And that was one of the ones I told you definitely remember. And that it establishes and does it across. Typically using a file transfer program to use file transfer protocol. So FTP uses FTP, and both of those are known as FTP, program and protocol. So you've got to be careful on FTP. Are they talking about the protocol, or are they talking about the program? Questions on that? And then the last one they mentioned to you in the chapter is SMB, Service Message Block, which is another way to share files across between them. They throw you that one. It is a fixed size delivery on it for sharing your different network resources. I really haven't ever seen much on SMB and never have seen much pushed on it. Okay? And so SMB is out there. The name of it is not quite as clear on it because it is server message block when it's really sharing resources, okay, like files. But if you're going to transfer a file, you're going to use FTP. And you can do FTP through your browser. Instead of doing HTTP colon and an address, you can do FTP colon / address. And if they've got an FTP server there, you'll hit the FTP server. And you'll do that sometimes, okay? And a lot of times FTP is running there in the background on you. Like if y'all go to pull down the file from Azure DevTools for teaching, you're actually using FTP to do it, but you're not going to directly. They've got you going through HTTP working around with FTP. All right, questions for me? That gets us through 15. Next week, we will do 16, and I'll probably go ahead and go over 17 next Wednesday. We're going to talk a little bit about security in 16 for network. And then 17, there's not going to be much for us to go over about it. It's really where you're taking what you've learned through the book to build a network from it. Okay? To build a simple, small network. So they sort of wrap it all up there in that chapter. And then, and ideally, I'd like to get those done next week, although 17 is really non-signed to the following week. And then that last week, plus that last Monday, because y'all are Monday and Wednesday, so we do have through the 3rd for y'all to work on getting your cabling done. Because you will have to do it now with no assistance, but if you haven't finished the midterm one on it, where you did it with assistance and got all 3 cables made, you got to do that first before you start working on doing it for the final, and you've got to do the lab final to pass the class. Does everybody follow on that? If you don't do the lab final, or you don't do the final at Medicad, which does make you do, of course, feedback out there at Medicad. If you don't do those, it doesn't care what. If you don't do one of those, it doesn't care what the average you got here in the class is, you'll fail the class. And that was on the syllabus from the beginning. Those are all 3 mandatory items. Well, there's really 2 mandatory items now effectively, because they won't let you do the final at Medicad without having done the course feedback first. It will make you do the course feedback when you start the final if you haven't already done it. And y'all should be able to go ahead and do it now. I think I've got course feedback active for you out there now. It's about 7 or 8 questions is all it is, and where they ask, did you learn stuff in the class? Was the class effectively presented? And a few other broad questions on it. They do it in every class. Where when I'm taking a Cisco class, I have to do it every time. And so like I'm going to take a DevNet this summer from them. When I get to the end of that class, I'll have to do that identically same course feedback you got to do in here. Although I've really not ever seen the results of any of it, but they've not made it easily where I see it. And it's just for Cisco's information pretty much. You should have gotten in your email probably this week or within the last real recently on it, a thing about course evaluation for the school. They give you a link to go to evaluate each class. So you should have gotten one, actually probably 2 emails on that, one about the link to Ms. West's class and one to my class. Please do those also. I know I look at them and I make changes in classes based on it. Pay attention to where y'all make comments on things were really good that went in class, or things that you didn't like in class, or things that could be done differently. Some things I can't change, that even if all of y'all said it needs changed, like if you all said that don't make the final lab the mandatory, it can't do anything about that. Cisco sets that requirement, okay? So some things I can't change, but some things I can when I look at it. And I have made changes on classes based on feedback in there. So I do go in, look at those and read those. It was used on our faculty evaluations for a while, although I think now from what they said recently, I think they took that back off our evaluation. That was what the students rated us on. They had a piece of it that took the average of all of the student evaluations. Personally, I liked the idea of that being on there. It was just a piece of it, and it was just like a half point out of our 5-point score or whatever. But there's a lot of faculty who didn't like that, I know. They didn't like the idea that students could determine if they got a good evaluation as a teacher or not. Well, personally, I think y'all are the ones that can best determine whether I effectively taught the class or not. Now, employers, bosses, etc., can determine whether I did also cover material I should have. Bosses probably not as much on that one, but employers definitely can. And the boss can determine whether I was in here on time every day and whether I had the class or my online classes, if I did discussions, etc., or if they came in here, did I have interactivity among y'all and got y'all to participate, not just me talk every day the whole time. And obviously y'all had lab time and stuff too in here, so you've had time to talk too. And I've tried to encourage y'all to ask questions at times. So that's what we'll do next week is we'll probably wrap up the lecture next week. But still, if y'all have questions the following week or that Monday, y'all can ask. The final exam will be available from Saturday, May the 1st through May the 4th, which is Tuesday. Okay? Make sure you take it in that time period. So I do have it. I intentionally set it that way because with my online classes, some of those students only can work on stuff on the weekend, and y'all may be the same case, okay? And some students can only work on stuff during the week. Notice by me doing Saturday through Tuesday, it's available during the week and on the weekend. So everybody should be able to find the hour or so to take it. It's going to be just like your chapter test, your module test work, okay? As a matter of fact, it comes from the same test bank, so question, there's a good likelihood you will look at questions, go, I saw that question before. Although they are running from a bigger bank on it nowadays. They used to be that they just had a real small and everybody got exactly the same test. Now they've actually had test bank out there. So it does vary some. All right, any questions for me? So Monday, we'll do 16, and Wednesday, if we have the chance to get to it, if we get through 16 on Monday, which I think we probably will, we'll briefly go over 17, or even if we don't get through 16 on Monday, we'll finish 16 on Wednesday, and then probably briefly just mention what's in 17. But all it is it's going through, and you've been doing this stuff all semester anyway, so it's not new stuff to you. It's going back through the commands to set up your devices and set up your network. So you're building a small network on Packet Tracer in that one. And that's actually what your assignment will go with it is. Okay? But they've had you already doing the stuff all through the book. So it's not something. In previous editions of this course, that they had it, that was the first they even told you anything about getting on the devices. You didn't do anything on the devices till you've already done stuff on the devices. Now they're sort of putting it together at that point for you. Okay, any questions? Then that will wrap it up. I'm going to stop the recording. And then y'all can, about 15 minutes till it ends, but y'all can do whatever y'all want to do at this point.